Welcome back, everyone. In this video, we're going to take a look at a very brief introduction to Yara because I've already used it in several videos in the past, and I have quite a few videos or content planned around it. So I wanted to make sure that I gave everyone the opportunity to establish a baseline with me. So first and foremost, Yara is the Swiss Army knife of pattern matching. And it's used kind of ubiquitously to create signatures, to create rules, define patterns within those rules, and then detect things that you want to detect. And that can be binary content, files, HTML pages, pretty much anything that you can think of that you can write a rule and then use the Yara engine to match content against it. Probably the easiest way to get started is just going to yara.readthedocs.io. Here you'll find information about getting started, compiling and installing. So you'll have several different options here for installing Yara. I'm not going to get into the details here just because the installation path on pretty much any operating system that you're using is rather straightforward. On a lot of Linux distributions, you're going to have package managers that'll just allow you to, apt install Yara. Even on Windows, as I've mentioned in some of the previous videos, using Chocolatey, you can Choco install Yara, and that'll not only install it for you in the system, but then add it to your environment, add it to your path, so that when you open up a prompt like you see here, this is a PowerShell prompt, you can just run Yara. So I'll leave the, again, the installation up to you just because there's enough variation and I think it's relatively straightforward. Of course, if you have any problems with that, because as soon as someone says it's relatively straightforward, someone's going to have a problem because there are just so many variations out there. So feel free to drop a comment and I'll definitely take a look and help out if I can. Now, beyond that, I would highly recommend just taking some time and reading through the writing Yara rules section. Even if you are somewhat familiar with Yara, this is going to give you an idea of all that Yara can, and probably more importantly, can't do. Because once you get an understanding for what it can do, and you start writing rules, if you aren't already, then as you start to write more complex patterns or think of more complex scenarios, then you'll have to understand what you can't do with Yara, and there certainly are some limitations. So this will provide you with a good introduction. You don't have to read it word from word if you're not interested, but at least skimming through it will help you to understand all of the basics of getting started with Yara. And of course, throughout the videos that I use Yara, I'll demonstrate a lot of these concepts. But for this video, it would just get too long if we went through it. All the details provided here in the documentation, and I think you might find that to be quite boring. So let's jump into Yara. Once you have Yara installed and you can run it, so let's see, I have my PowerShell prompt open. I don't need to install it because I've already done that. Once it's installed using Choco, you have yara64.exe. So you can open up your prompt, open up your terminal. You should be able to type in the word Yara, hit enter, and get some basic usage information. Again, all the help information here is going to largely be echoed, if not echoed in more detail on Read the Docs. Getting started with using Yara is rather straightforward. We just need to have a rule and something, or rules, and then something that we want to compare against it. So for this quick example, I have testrule.yara and I have an executable, which I've used for some of the previous videos. The file that we're matching against, there really isn't important in this case. We'll use it for the demonstration here, but the concept of writing a rule and then matching against some content. Now, I haven't written the rule yet, and you'll probably find that, getting started with Yara, you're going to consume probably more rules than you're going to write. And where you get those rules is really varied. There's a lot of great projects out on GitHub where you'll find Yara rules. There is going to be different threat intelligence platforms that share those with you or allow you to view those. And so you can find them kind of scattered across the internet. I think if you go to GitHub and look for awesome Yara, that's probably a good place to start, because that'll allow you to just start looking at all of the projects that have Yara as a center point. For me personally, I not only use those, but then as I spend time looking at malware, reversing things, I tend to create Yara to help me detect certain techniques, certain packers, certain malware families, and a variety of things that I use in a variety of different contexts. And then that repository of Yara really grows. And I would imagine that a lot of, researchers, reverse engineers are very similar in that you have your, we all have our sort of collection of secret Yara sauce that we use and have grown over the years. So when it comes to writing the rule, then I tend to just use a text editor. This is Visual Studio Code. It's, again, fairly straightforward to get started. And the first thing that we have to do is define our rule. So using the rule keyword and then the name of the rule. This is limited to a certain number of characters. I don't actually remember off the top of my head because all of my rules tend to be alphanumeric, and then anything that I want to separate is going to be with an underscore. So you can check out the Yara rules documentation. That might have some best practices there. Otherwise, the naming convention that you use is either up to you or maybe up to the organization where you're working or where you're contributing those to. Okay, the next thing is to look at the body of the rule. And there's going to be three main sections. There's going to be the meta section, which contains metadata. And so the values here are going to be separated, key value pairs separated by an equal sign. These can just be arbitrary values. You'll see a lot of Yara rules will probably have information about the author. They might have a description field. That's always helpful so that you, even for yourself, so you remember exactly what you wrote the rule for, what was the intended purpose. You might have a sample where you have a hash or something that you're annotating here to say this is the thing that I base this rule off of. Dates, if you're not putting them into a system that's putting a timestamp on its creation for you, dates can also be helpful. Again, they're kind of arbitrary. Some systems that I've worked with will certainly parse the meta field and or require then certain fields to be present and have a value as they use them to help manage the rule in like a broader framework or a broader system. But I don't have any, for just basic getting started, we don't need any of that. The next section is, one of the two most important sections, and that's going to be the string section, and then we'll have the condition section. Okay, and you can kind of infer from the name of the sections what goes there. For strings, that is the content, essentially the patterns that we're looking for. Strings, hexadecimal values, regular expressions, there's a number of things that we can define here. And then the condition is just how we want Yara, how we want that engine to apply the strings to look for the patterns and determine the match. So if we take a very simple example, we define a string, much like we would a variable in a lot of different languages. If you read the documentation, it says this is supposed to be a C-like language. So $, and then the name of our string variable. And the simplest is just to wrap whatever string we want in double quotes. Now, you'll read in the docs, there's a bunch of, kind of modifiers that come after the signature, such as no case. No case just says, hey, I don't care about the case sensitivity. So when you're looking for this particular string inside of whatever we're matching that content in, normalize it so that we don't have to care about case sensitivity. You have ASCII or wide characters. If you're looking for example, if we want hello to actually be a wide character, which means that each byte is each character is multi-byte rather than a single byte with an ASCII, we can define that here. We don't have to worry about defining that in our string ourselves. So there's a number of very helpful, again, as I start to use those in more complex demonstrations in the future, we'll talk about that. The other is to define hexadecimal values. So we can define, let's say we want to look for the pattern E8 followed by 2 null bytes. Right, so E8 being a byte, or each 2 hexadecimal characters being a byte value there, and much like, so that's what we can define. We can look for. We can define regular expressions. Right, I'm not going to do that particularly in this demo, but we can use regular expressions to sort of broaden the pattern that we're looking for, and then similarly, we can use wildcards and other kind of special character sets in order to define or make the the sequence of bytes a little bit more generic. So we have definitely some options there. Now, when it comes to the condition, then we have to define how we want these strings to match. So you could say something like S1 and $S2. That condition is simply saying that we want both strings to match. We can use logical operators and or, and then we reference our string variables that we've defined up above. There's also a number of sort of keywords. So we could say one of them, or we could say any of them, or we could say all of them, right? Depending on what we feel is the most appropriate way for the strings to match in the content that we're looking to detect, right? So that's the basics of it. Now, again, your strings can get much more complicated, much more complex. Same with your conditions; they can get much more complex. But this is just to get us started. One of the things to keep in mind, and one of the things, at least that I've personally experienced with Yara, is that it's part science, it's part art, and knowing how to create a good signature comes with time, it comes with experience, it comes with looking at other Yara rules and reading blog posts and all of the things that sort of come along with activities in cybersecurity. So don't worry about that aspect of it right away. Learn how to write rules first, and then as the more you write and the more you test them, the more of the skill of determining what is a good rule and what are good patterns will come. Okay, so once we think we have a rule, then what we can do is we can actually test it, right? So now we can go back to our command prompt. We have Yara ready to go. Again, the most basic invocation of this is just to say, I want to test this rule file against this thing. And if we have no matches, we get no output. What happens if we get an error or have a syntax error? So let's create one by removing a required bracket, saving our file again, going back to our terminal, running it. Now you see we get an error. We have a syntax error, and it's not terribly helpful, but it is directing you to line 10, which in this case, looking at line 10, we might be able to quickly visually identify that missing angle bracket. So the process of sort of debugging a Yara rule can be a little bit tedious in terms of the back and forth. Now, with that being said, there are some tools that help debug Yara rules. And again, that'll be a topic for a future video. If you don't hang out for the video or don't see it soon enough, definitely search for some Yara debugging tools, because they are out there. What else can we do with our strings? Well, we can do neat things like, let's define another one. And we can have, again, more complex conditions. So I could say something like, I need to require string 1, so $R1, and I want to allow, I only need one of $S asterisk, right? So we sort of wildcard the S pattern. See, I was using S1, S2, S3, S4. We can wildcard that and just say, require 1, and then I only need one of these 2 strings. Okay, once I've made that modification to the condition, it's probably a good idea to come in here and check it. And of course, we don't have any matches because we didn't see any before. I guess I shouldn't say of course. Maybe that change in condition was enough to say only one of those, S conditions or S strings, but then we added the required one. So again, don't worry about the values that I'm using right now, because it's more about the mechanics of how the Yara rule actually works. Okay. Well, what happens if we want to actually match on something? Well, these really aren't going to work for us. So I'm going to remove, we'll create a couple of strings here, but I'm going to remove the required string that I had. And then we'll just say that our condition will be all of them. So where could we get the content to match on? Well, let's say that we are looking at our, in this case, a piece of malware, and I have an unpacked executable, and creating signatures for the unpacked executable can be tremendously valuable. Creating signatures for the packed version of that or the obfuscated version of that can also be very valuable, perhaps a little bit harder based on, or depending on how how they're obfuscating and how they're packing it, and then how much variation you see there. But we have a target. Now, if we just run strings, you'll see that we get a lot of content. That's to be expected, because that's just how strings works. It's looking at the binary content, and it's just pulling out sequences of characters, sequences of bytes that it thinks is a string. A lot of it is, a lot of it isn't though, because it just happens to be a sequence of bytes that falls in that printable ASCII character range. So we can still use strings, and we could maybe, let's say for this demo, I want to define my string to be a length of at least 10. The default for strings, I think, is 8, maybe it's 6, but it's a shorter version. 10 is certainly much larger. And then we could grep on some values. Well, we don't have to grep. Maybe we just run this and see what we get. In this case, we still get quite a bit of output. And if we just scroll back, I have some strings in mind. Here we go. Right here. All right. So we have a handful of things that are certainly important strings for how this particular piece of malware operates. Now, these could be good strings just in terms of, strong indicators because they're very clearly associated with this malware. They have something to do with how this malware is, performing command and control or sending the data theft. However, these tend to be a part of the configuration, so they tend to change. So let's say we wanted to detect all of the unpacked versions of VDAR, but for these are only valid C2 for this particular campaign, which might only be a handful of samples. So we wouldn't necessarily want to do that. Again, that falls into part of that art of developing Yara, knowing what's a good pattern. So we'll start talking a little bit about it. But again, I'm not going to get too much into the weeds there quite yet. If we look down a little bit further, though, you'll see there's some what are likely the percent, and then different parts of the different. We have the percent signs, and then what appear to be different paths in the operating system. So probably places where it's looking for to I don't know, persist or steal data or something. So those could be those could be a unique enough pattern with this particular sample, or because we can define multiple strings, maybe we add some of these, and maybe we look also for some additional strings. If you keep scrolling down, you'll see there are parts of the HTTP header, as well as we're looking at registry key locations and others. So we can start to find enough patterns, and really the important part here is that we find enough patterns that we think are unique enough to identify this and nothing else. So let's just say that this string, and I'm going to copy that into my clipboard, and we'll define it as string 1. Okay, if we wanted this to be a regular expression, which again, we'll talk about that in a future video, we would use the forward slashes in order to define, and then the content within would be the regular expression. So when we define a string using the double quotes, we don't have to necessarily worry about special characters here because, for example, a /n, if we wanted to actually look for a new line character, we'd have to use a regular expression. If we wanted to look for the characters \n, then we would use a string. So we don't have to worry too much about those percent signs. And let's also grab one of these DLL names. Okay, we'll copy that. And similarly, we'll wrap it with double quotes. Okay, once we have those defined, we can save our rule. I'm going to clear the screen, and we'll just scroll back in history. Oh, I went too far. Okay, and then we'll clear the screen, and now we're ready to test our rule. So same command, the only thing that changed is that we've actually got content in our rule. We have strings, we have conditions, and now when we test against that executable, you can see that we have a match. So this is, you're going to get as a result the name of your rule and then the file that it matched against. Okay, so there you have it. I guess kind of a long-winded explanation, but hopefully you have the mechanics, the basics, and a number of things to start thinking about, considering researching, or waiting until I get those future Yara videos posted. If you have any questions, comments, feedback, please drop them in the comments section. I look forward to seeing those. Otherwise, I hope you enjoyed the video, and I'll catch up with you all in the next one.